Chapter 10.
One, two.
What did they, what?
Yeah, you would make it 4 rows over.
Hey, a little different on this vocabulary sheet this time. I want you to honestly go through this tonight, and I want you to try to write an actual definition for this, okay, on the back for each one, or you can put it on another piece of paper, I don't care. But then you'll go through and you'll look throughout the chapter to see if you knew what it was or if you didn't. All right? So, today we start circles. What is a circle? A shape that has no angles.
Enclosed figure. Enclosed
Okay, it's an enclosed figure. Has no angles. What else?
360 degrees.
What is straight?
Okay.
Curvy.
Yeah, but I had them.
No straight sides. Don't have no straight sides.
I'll get it.
No corners.
Has no straight sides yet. No corners. All right.
I'm thinking probably why.
So the actual definition is a set of all points okay, that are a given distance from one given point. And this given point right here is going to be called the what of the circle?
Center.
The center of the circle. Okay? So the center of the circle is really important. So let's try to draw a circle. And obviously our center is going to be dead in the middle, hopefully. So it's a set of all points that are a given distance from that one point. So around here, it should always be the same thing. So again, this is my center right here. The center is important for multiple reasons. Number one, it is how you name it. And how you name it then is by a capital letter. And as I told the 7th, we actually did this in 7th grade today too. So we're doing the same exact thing. So we come over here, we call it C for circle. And a circle, let's come back over here and say that a symbol is just a circle with a dot in it. So like when we had an angle, or if we had a line or whatever, you had a symbol, it's the same concept has to apply here. So if we're going to name this on a quiz or a test, we're going to say circle C, right? Okay? So we know that it's always the same, or that's how we're going to name it. And then from there we start having specific vocabulary words, and our first one would be this right here, right? So we have a segment, because there are endpoints, and if we call this C and we call this R, so this particular segment is called the what?
Radius.
So my second vocabulary word would be a radius. And a radius is simply what? How can I describe it? The distance from what?
Side to the center.
The distance from the center to the side or to the edge of the circle. So, what's the plural of a radius?
What'd he say?
He said circumference. So the plural of radius is radii. Two i's at the end of radii. So here's the question. How many radii are in a circle? As many as we want, really, right? As long as we can keep drawing little lines, we can just keep going and going and going and going, and realistically, you can keep splitting that in half and splitting that in half. So there's really an infinite number of them, right? Number of radii. So here again, then, this is shown by, and this is really important. Whoops. I combine the two. Lowercase r. And this is what this is really important that you use lowercase r. There's going to be a lot of variables in this, and you really got to know the difference between if it's a lowercase letter or if it's a capital letter. Okay? What do you know about radii in this circle? So if I call this one RC, obviously it's a segment. So we're still going to write it as a segment. So you need that little bar over top of it. Okay? If we keep putting more in there, it doesn't matter what we call it, right? It doesn't matter where it goes. They're all the same, right? So this would be KC. Doesn't matter if I say KC or CK?
No.
Absolutely not. All right? But what do I know about in this particular circle? All of those radii. They have to be the exact same distance, right? Okay? So again, because it's a distance, you should have a label on it at the end too. Whether it's inches or whatever, and they'll tell you what that is, okay? Everybody okay with that? So then we go on to something called a chord. And what's a chord? Any idea? It's not a musical chord. Okay, so we got a bunch of different versions of chord, right? We got a musical chord, we got a chord on the fan. This is a chord here, right? So what's a chord? Well, a chord is a segment with both endpoints on the circle, or on the outside of the circle, if you want to say. So it's a segment, so if we come back here and we draw a chord, we still can call it circle C. A chord just has to have its endpoints on the edge of the circle.
Oh, it doesn't touch the side.
Okay? So we can call this RS. Alright? They can intersect. So this is where the things start to get complicated. Because there's going to be certain rules and certain things that tell you what special chords are and what their relationship are. Okay? That's the complicated part of all this. So then we have a special chord. And my special chord is the what?
Radius.
Not the radius, but the what?
Circumference.
The diameter.
That's what you read.
No, I did not.
Gabriel?
Sorry, I did not. It's foot line, you gotta know that.
So, what's a diameter?
All the way across.
So, it's still a chord, so the definition of a chord fits, but we have to say then what?
It touches the center.
A chord,
Goes through the center.
there you go, that goes through the center. So, think about this, don't say anything out loud so everybody has a chance to think. Why is this also special? It's gotta be the what chord of the circle? The what? The biggest or the longest, exactly right. So the diameter is the longest chord. Every single time, right? And when you draw this diameter, okay, so we come back here and we draw a diameter, it's still a chord, so it's gonna, whoa, that's really bad. I'd really want to use a ruler probably. And we call this one, what do I got here? E and F. Okay?
Do we have to have the dots on the ends of the lines for it to be a chord?
No, not necessarily, but they're probably going to have them on the.
Just like on here they don't.
No.
It says like identify it.
So yeah, it's just easier for me to, I guess, show that it's actually a dot. But okay. So my BF is my diameter, and when any diameter splits a circle in what? In half. So we make a semicircle. And if we have a semicircle, we know then that this is going to be 180 degrees, right? So we didn't really talk about degrees, really. But we'll get into that here tomorrow. Okay? Diameter is shown by, and again, this is really important, lowercase d. A capital D, most of the time, or when we do d equals RT, we have d also, but that's a distance, so you just got to know that there's a difference. And then obviously, what makes a diameter also special? It's actually 2 radii, right? So if it's 2 radii, I know that 1 radius is half the diameter, as long as it's a radius, okay? So people are going to get going really fast on the quiz and the test, and they're going to start flying through this, and they're going to say, well, they're going to say VM is a diameter, and we're going to say that that's wrong, right? VM is a chord, not a diameter. Good enough?
Because
Yeah.
the diameter has to go through the center.
It has to go through the center, exactly right. From there, then we talk about circumference. And what's the circumference of a circle?
Perimeter.
It's really the perimeter. It's a fancy way of saying the perimeter, right? So let's put that in quotation marks and say the perimeter of the circle. So what does that mean? If it's the perimeter of the circle, it's the what? There you go. So it's a distance around the outside of the circle. Okay, so it's a distance. 1 full revolution. And so then you would use circumference to find that formula for circumference. So here again, make sure that you understand that this is capital C. And then my circumference is usually found by pi times d. Everybody understand what pi is? Pi is several things, right? So if we come over here and we say pi is equal to, most people say it's just 3.14, right? Okay. Remember now you got, if you're going to use your calculator, you have a button on your calculator. But if you hit that button on the calculator, this is going to say 3.14 and then put some more stuff. What's it say, Mr. Nose? So one thing is make sure that you can find pi. Okay? So that's what Mr. Nose is having trouble with.
3.141592654.
Okay, so it keeps on going, right? And way back in the day, they honestly thought that pi was an irrational number. That it went on and on and on and never repeated and it never terminated. Well, some really smart dude finally figured out that it does stop. And I can't remember how many places it stops after, but it does stop now. Okay? So a lot of the times, I don't care how you use it, I'll do it both ways. Okay? But again, if you use the button compared to 3.14, and you're comparing answers if you're going to do the homework, Zoe gets an answer using 3.14, and Naya gets it by punching the button. Are they going to have the same answer? No, because Naya is going to have a bigger answer because why? She's got more decimal places. And it doesn't seem like it should make that drastic of a difference, but as your numbers get bigger and bigger, it's going to be a lot of difference. Okay, so I don't care how you do it, I'll do it both ways. Just be consistent with yourself. Okay, so if you're going to use the button all the time, use the button every single time. If you're going to punch it in as 3.14, use 3.14. And then realize that this is also, pi is also this fraction, right? 22 over 7. So if you ever hear 22 over 7, you just know that that's pi too. So when we say this is circumference, it's capital C, and then pi times diameter. We just punch them into each other. Or, because we can write diameter as what? 2 radii or 2r, we could also write it as 2 pi r. And this is one formula right here that gets messed up quite a bit, because a lot of people just want to say what? A lot of people want to say pi r squared. But pi r squared is actually the what? The area of the circle. Now we haven't got to that, we're just going to do the circumference. But it's a distance, okay? And this is really important that you know the difference. Okay? Any questions there? So we'll show you problems that you have to figure out how to get the circumference here in just a little bit. From there then, more just kind of vocabulary words, but we talk about inscribed versus circumscribed. Now they both involve a circle, but if you have something inscribed, what's that mean? It's going to be, what'd you say, Ms. Streckman? Inside. So if it's inscribed in a circle, it means that I'm going to draw a shape on the inside of it. It could be an actual square, or it could just be some random quadrilateral like this. It could be a triangle. It could be a pentagon. Doesn't really matter what it is. Okay?
So it's this line, it's the line or the space in between?
It's the shape. The quadrilateral is inscribed inside the circle. Okay? Whereas circumscribed is what? Circumscribed is basically drawing a shape. Okay? And then you're going to do the same thing. But it's basically the perspective that you're looking at. Okay? So you would say the circle is circumscribed to the shape here. This one, you're going to say the shape is inscribed inside the circle. So basically, they mean the exact same thing. It's just the perspective that you're actually talking about it. Are you talking about it with respect to the shape, meaning the one with actual sides, or are you talking about the circle? So the circle is circumscribed around, the shape is inscribed inside. But basically it means the same thing, that the circle is going to be on the outside. It's just how you're talking. So you could use this in the same paragraph describing the exact same thing, but here you're describing the thing on the inside. So this quadrilateral is inscribed into the circle, but over here you would say the circle circumscribed the triangle. It's just a different way of looking at it. So it's the perspective, okay? of how you're doing it. Again, that's just more of an introductory kind of thing, but it might come up if you do the homework, okay? And then the last thing that they also talk about in this one are called concentric circles. Any idea what this means? You probably have done this, well, as a little kid, maybe in the bathtub. Okay. If you have a swimming pool, if you go to the pond or the lake to go swimming, okay. Concentric circles means if I was on top of the house and I was looking down at a swimming pool and I dropped a ball, okay, and it hit the middle of that pool, what would happen? It was like ripples or waves, but if you would actually see it from the top, each one of those is a circle. And it just keeps widening and widening, so those are concentric circles. They just keep on going and going and going. Okay, so if we think back to what we've talked about before, are all circles congruent? Are they congruent? No, right? Because congruence means what? The same size. Are all circles similar?
Yes.
Yes, right? They all have the same shape. They just get bigger or smaller. Okay? So that's what concentric circles are in a sense. When you throw something into the water and it just keeps making those ripple effects. And then you would just see it circle and circle. Sooner or later it dies out, right? But they would have always have been there. Okay? Questions with the words? Alright, so from there then, let's look at some examples. Again now, as we go into this new chapter, we will not have necessarily homework, but you'll still be given some problems. And all of the problems will relate to things that will be on the quiz. Okay, so in this one right here, again, don't say anything out loud. Let everybody have a quick second to think. Okay? Name the circle. Okay? So what are we going to name it? E. Now, don't say this one out loud. How many radii are shown? Now, yes, you could say an infinite number because that's what we said earlier. But how many radii are actually shown? Just 2, right? And we would name them what? BE or ED. Exactly right. And so, do I know that BE and AC have a relationship? No, because AC would be considered a what? It's a chord, right? It's a chord. But we really don't know anything about that chord. But we would know that BE is equal to ED, right? Because they form a diameter. Okay, now, here's the other thing. Most of the time, when you start doing these kind of problems, like in the directions, and I know some of you don't like to read, or don't know how to read, or whatever, okay? But you gotta read the directions this chapter, because it's gonna tell you what those segments are. So, you know how the book sometimes, it doesn't always look like it's a straight line. It kind of looks like it veers off. But the directions, if the directions say that BD is a diameter, even if it looks like it veers off in the book, you gotta go with what the directions say. That makes sense? That's really important now, okay? It's really important. So again, that one hopefully was pretty simple. Then obviously we can get a little bit more complicated. Okay? So, again, how many radii would you say are in this shape that are actually shown?
30.
What about NT?
No.
It's a chord, right? So, would you agree, would you say that FN is perpendicular to AT?
Yeah, but
Do I know that for certain?
no, but it looks like it.
It looks like it, but I wouldn't know that for certain, right? Would I know that FN is equal to AC?
No.
Would FN be equal to AF?
Yes.
Is AT a diameter? Again, it looks like it, right? It looks like it. Realistically, we can't even say that for this. But normally, if it goes through the center, unless you can really see that it makes a jut one way or the other, then we would assume that it is. Everybody all good with that? Okay. And then we start looking at some problems. So if RT is equal to 21, what is the length of QV? So RT and QV. So again, we'd have to make sure that we assume that these are truly diameters. Now they should probably tell us that. But even though that we're talking about segments in two different chords, we could still answer the question, right?
Yeah.
So if RT is 21, what's QV? Right?
Yeah.
All we're going to do is divide by 2. Okay? Piece of cake, huh? So these ones get a little weird, and some people don't like these ones. Alright? So read this one carefully, and try to see if you can interpret what you're going to do. The diameter of circle X is 22 units. The diameter of circle Y is 16, and WZ is 5. Can I find the whole thing? Meaning X to Y. Everybody got an idea? Everybody got an answer?
Yeah.
You don't look so sure, Tess. What do you think? What'd you do? 22 plus 16 and subtract 5?
Add them all together.
You divide 22 and 16. Add 5. Yes.
You think it's 24?
Yes.
What?
11 plus 8 plus 5.
11 plus 8 plus 5.
That's 24.
Why?
Because X, so the diameter of X is 22, you divide that by 2, so X to Z is 11, Y to W would be 8, and then so 11 plus.
Okay, so here's the question. Do I want to include that 5?
No,
No.
it's in both of them.
It's in both of them, right? So if 11 is my radius and 8 is my radius,
It's 19.
it's how much?
19.
That's 19?
I
You
got
subtract 5?
Yeah, 14. Yeah, 14.
Tess says it's 14.
That's
I have 9.
You have 9? Okay.
I'm confused now.
Alright, so, when in doubt, we gotta start writing things down, right? I know, this kills most of you, to actually write things down. This is how much?
Oh, wait.
11.
11.
This is 11. This down here?
5. Oh,
8.
So you subtract.
How many times do I have to count this?
0.
0, right?
So it's 19.
Wait,
No, you have to subtract.
Oh,
You
it'd be
subtract 5 because there's 5.
it'd be 15.
okay, here's the question. Do I subtract 5 from both of them?
No.
No. Oh, yeah.
This is grand total, right? So do I only subtract 5 one time. So what's 11 plus 8 minus 5?
14.
What did you say, Tess?
14.
Good job, Daniel.
I don't know.
Alright, Gabriel's still doubting you, Tessa.
And then we subtracted 5. So we got 12. Or 14. And we subtracted 5.
14.
Let's go, I got
Well, you subtracted 24. You subtracted 5. Then subtracted 5 again. I was like, I was confused.
Yeah, I got 10.
Yeah, if I'm going to
Alright. I gotta go back to erase this one, sorry.
I have 14 off the bat.
Make a good, that was a good one, right?
Yeah.
Sure.
Gabriel? I don't need your, sarcasm.
Sure,
I don't need
sure.
your sarcasm.
Sure is attribute, yes.
Where's my eraser?
It's not
It's
available.
right there, it's not available.
Well, that's what happened.
We can do it.
Alright, don't look, Gabriel.
I never look. Absolutely.
Alright, so now we got 3 circles.
I accidentally saw it, it's okay.
So don't look at it, don't say anything out loud. If you saw the answer, don't say anything out loud. The diameters of D, B, and A are 4, 9, and 18 respectively. Can I find AC? So the first thing that you gotta really zone in on is where's AC, right? That's what you gotta think about,
Yeah.
Got it.
okay? Anybody got a guess?
7.
C.
Why?
Because the whole thing of B is 9,
Okay?
and then it's half of D, and D is 4, so if you subtract 9 from 4. 9 minus 2 is 7, so it's 7. That's what I'm trying to say.
So since
It worked in my head.
So since it's inside of it.
Press the button, we'll see what's right.
You're right.
It's always.
Hey, Karen, I know what you're trying to say.
Said you get a bit more sense out of it.
Oh, yeah, that's
Then subtract it.
It's not.
Minus the radius
Nine minus
of D
Another way of saying it.
equals.
Wake up.
Alright, so again, make sure that you take the time to look at the information given to you. A series of crop circles was discovered in Alberta, Canada. Ever seen something like this? Even in a picture?
No.
Yeah, it's kind of alien stuff. It's actually kind of cool. Okay, so if you have never seen something that, look up crop circles, and it'll show you like weird designs and stuff in the middle of a cornfield.
Oh.
Okay. The largest of the 3 circles had a radius of 30 feet. Find its circumference. Okay, so here's a couple things. If you're going to do the homework and you want to look and check your answers in the back of the book, they are probably going to write this answer as. So again, if it says it's a radius of 30 feet, how can I find the circumference? 2 pi r. So I'd have what?
Or you just do.
What's 2 pi r? In this case. What?
30 times 5.
30 times pi. In the back of the book, they will leave it as 30 pi. Okay? I don't like that. If you have something like that, always punch it into your calculator. Don't just leave it that. And then make sure that you have a label. And my label is going to be what in this case? Just feet. So, obviously, pi is 3 point something, so it should be roughly 200 and what?
180.5.
Or sorry, 30 times 3 is 270.
No, you have to double it, because that's the radius. So
Yeah.
60
What did you say?
60 times 5, which is 180. 27.
180. You're right. Alright? And then don't forget that you need a label. Okay?
Nice calculator.
Do it in your head. Do it in your head. Do it in your head.
So, in the book, they would say find the exact circumference if they want you to find the answer into a decimal form. So, we would assume that we're always going to find the exact circumference. Okay, so, here's a question. Can I solve this problem for you? Don't say anything out loud, let everybody think for a second. Can I solve this problem right here? This revolves last chapter, right?
45, 45, 90.
This is a special right triangle. Because why?
The two radius are equal, so it'll be 1, 1.
Exactly right. So if you don't remember that this is a 45, 45, so this is my ratios of 1, 1, and the square root of 2, you honestly probably can't do this problem.
How do you know it's not 30?
How do I know? Because the two lengths that I have ones by have to be the same thing because they're both a radius. So then I'm going to do 3 square root of 2 divided by the square root of 2, so my radius is actually how much? 3. And then I can use that number to find my circumference, which is 2 pi r, right? So I'm taking 3 times 2, which is 6, so I get 6 pi, so it's just about what? 18.5. Now, notice this one right here doesn't have a label, so then we would just put what? Units.
So that line is congruent to the radius?
What?
This line is congruent to this line?
No.
No, that's your hypotenuse.
But I took this problem right here, I took this angle right here and divided it by the square root of 2.
Yeah.
Because I've taken this to get over here, so this is 3,
Yes.
and this is 3. So they're not
Okay,
equal.
so they're not equal, but, okay.
That's what you asked me.
Yeah.
No, I guess that was true. Okay? Everybody good with that?
Mr. K,
Yes.
is an inscribed angle the same as that?
Yes. Yes. Well, we'll get into it. Yes, but we'll talk about that tomorrow. Okay? So, again, if you want to do some problems, this is where you're at. If you don't want to do problems,
Like the last one.
I'll do
it's
it.
totally up to you.
I'm gonna
I'll do a couple.
So you
Okay.
just leave-
Did the Braves move on from Freddie?
I don't know.
Because they just traded for Matt Olson.
You can sleep now.
Apparently then so, yes. Don't want to get in any more of the Dodgers, apparently.
Have you, checked out March Madness yet?
No.
You have to watch the records over
I already did
I
mine.
have faith in March Madness.
Yeah,
My final four